Okay, good morning all. So today we will discuss the multiplication of two polynomials with the help of linked list. Okay. So see, suppose this is the first polynomial 3x square 5x plus 6, and this is the second polynomial 6x plus 8. So the two assumptions are there, in which first assumption is that the polynomials are arranged in the decreasing order of their exponent, like the exponent here is 2, the exponent is 1, and then exponent is 0. Okay, and here we can see the exponent is 1 and the exponent is 0. Okay, the structure of a node is look like this. First we will store the coefficient, that is a integer, then second one power or exponent, that is 2, and then the address of the next pointer, which is pointing to the next node. Okay, so three nodes are there in the first polynomial and two nodes are there in the second polynomial. How can we perform the multiplication of two polynomials? First of all, we will take first list, and we will take first node of first linked list, like 3x square. Okay, so 3x square is multiplied to 6x, then you will get 8 threes are so 6 threes are 18, and the exponent is get added to 2 plus 1, so it is nothing but 18x to the power 3. 18x to the power 3. So we will perform the resultant linked list creation, and then this is stored like this. 18 is stored as a coefficient of the newly created node, 3 is stored as the exponent of the newly created node, and one pointer is made, okay, which is pointing to the next node, which is coming up in the further multiplication. After that 3x square is get multiplied to 8. Okay, then this will become 8 threes are 3 eights are 24, and 2 plus 0 is nothing but 2, so it will become 24x square. Okay, so 24x square will be stored here, 24 will be stored here, and then the 2 is the exponent which is stored here. Now we have performed multiplication of this node with all other nodes of the second linked list. Okay, similarly, now the pointer of the first list is advanced. Okay, now we will consider this node, which is this node 5x. Now this 5x is multiplied to this node first, then 5x is multiplied to this node, and then we will accommodate the result accordingly. In the resultant part, the exponent are arranged in the decreasing order of the nodes are arranged in the decreasing order of their exponent at any particular point of time. Suppose we multiply this 5x and then this 6x. Okay, what is the resultant? This is 30x square. So we will start scanning whether any particular node exists in the partially constructed result with exponent 2, and if we get the node in which some exponent is already there and the value of that exponent is 2, then what we will do, we will not create the new node, we will just accommodate this result in that x square term. Okay, that's what we are going to do, and finally we will get this finally complete result. Okay, see the algorithm for the multiplication of two polynomial with the help of linked list. First we will take a pointer which is pointing to the first linked list, so set p to the first node of first polynomial. Then we will take the resultant linked list, initialize the linked list r for the 0 polynomial. Now we will take check while p is not equal to null, means first of all p is pointing to the first node of first linked list, then p is advanced. Now p is pointing to the second node of first linked list, then once again p is advanced, third time p is pointing to the third node of first linked list, and so on. Okay, similarly what we will do, copy list q is nothing but your second linked list, to a new list t, multiply the term pointed to by p to each term of t. What does it mean? So suppose, see the previous example in which p is pointing to this node, okay, and q is pointing to this node. So first of all, this P is multiplied to this, and then this Q is advanced. Now Q is pointing to this node, then P is once again pointing to this. Okay, so this list is completely exhausted. After this complete exhausting of this list, then P is advanced. Now P is pointing to this. Once again we start the same multiplication from the first node of second linked list. How can we perform the multiplication? There are two things in this: exponent and coefficient. So coefficient is get multiplied, like 3x square and 6x is multiplied, so 3 is multiplied with 6. That's why here coefficient is equal to coefficient multiplied by coefficient of P. And what about this exponent? This 2 is get added with this one, so here exponent of this T is equal to exponent of this plus exponent of P. Okay, and finally we will find the position of this partial result, and we will accommodate that partially constructed result in the already existing resultant linked list. After that we advance P. So now P is pointing to the second node of linked list, and we will perform once again this links. Okay, so this loop will get terminated while P is not equal to null. Okay, and when the value of P is equal to null, it means that first list is exhausted, because initially P was pointing to this node, then P is advanced, now P is pointing to this node, then lastly P is pointing to this node. After that this is advanced, so the updated value of P will become null. When P is equal to null, you will come out of this loop. See the more detailed version of this algorithm, or and similarly we will see how can we write the program for this. What is head 1? Head 1 is a pointer which is pointing to the first node of first polynomial. Head 3 is equal to null. Head 3 is nothing but polynomial of the resultant polynomial, and initially it is null because no such node exists in the resultant part. Okay, then this condition is there while temp1 is not equal to null or temp1 simply. Then what we will do, so initially temp1 was pointing to the first node of first polynomial, then temp2 is assigned to head 2, then once again we will take while temp2, then after that temp2 is increased, so temp2 is equal to temp2 arrow link. Now what we are doing, first of all we see this temp2, then one temporary variable is created. The name of this temporary structure pointer is temp3. So first of all we allocate the memory for this struct node star malloc size of struct node. Then we compute the coefficient and exponent of this. So coefficient is added. So temp3 arrow c is equal to temp1 arrow c multiplied by temp2 arrow c. So coefficient is get multiplied. Then what about this exponent? Exponent is get added. So temp1 arrow e plus temp2 arrow e. Okay. Now we will check if head 3 is equal to null. What this head 3 is equal to null indicate? This head 3 is equal to null. This indicate that in the resultant linked list no such node exists. Means this is the first result that we are getting, and it has to be accommodated in the resultant part. If head 3 is equal to null, then simply temp3 is assigned to head 3. And if this condition is not true, it means that some results are already there in the resultant linked list, then you come in the else part. Now what we will do, we start traversal from the first node of the resultant linked list. So what is the first node of resultant linked list? The first node of resultant linked list is stored in this head 3. So initially we will take a is equal to head 3, and we will take one more variable previous which is also pointing to head 3. Then once again we will check while a is not equal to null and a arrow exponent is greater than temp3 arrow exponent. What is temp3? Temp3 is the newly created node. Okay, when this condition is true, then a is equal to a arrow link, but before updating a is equal to a arrow link, we will store the value of a in some previous variable, so that will be used for maintaining the connectivity in the resultant linked list. Okay, now there are three possibility. What is temp3? Temp3 is the newly created node. temp3 is nothing but the newly created node. See the three possibilities. We are interested in finding the exact position of temp3 in the resultant linked list. Okay, now see this. This is case A, case C and case B. Suppose this is the partially constructed result. Okay, what is this result? 5x to the power 5 plus 2x to the power 4 plus 3x square. Okay, at some point of time you multiply one term of the first polynomial with the one term of the second polynomial and you will get this 6x. You will get this 6x. Okay, this 6x is nothing but your temp3, which is the newly created node. We are interested in finding the proper position of this 6x. Where should this 6x should get accommodated? We will start comparing with this. Okay, see in this, we will take a is equal to head 3 and previous is equal to head 3. Okay, so we will compare this. What is the exponent of this first node? The exponent is 5. What is the exponent of newly created node? Exponent is 1. Okay, just see here. A arrow exponent is greater than temp3 arrow exponent. Okay, so what is A arrow exponent? That is 5. What is temp3 arrow exponent? That is 1. So 5 is greater than 1. Then what we will do? We will advance this pointer. So A is equal to A arrow link. Earlier A was pointing to 5x to the power 5. Now A is pointing to 2x to the power 4. Now once again the exponent of this node is compared with the exponent of newly created node. Okay, then 4 is once again greater than 1. Once again we advance this pointer. So when you come here, then this is the node which is 3x square. What is the exponent of this? The exponent is 2. What is the exponent of newly created node? 1. Once again 2 is greater than 1. Once again A is advanced. Okay, now this is the last node. What is the link part of this? The link part of this node is null. Now the final updated value of A is null. See in this example, while A is not equal to null and A arrow link is greater than temp3 arrow link. Now A is equal to A arrow link, but before updating this A is equal to A arrow link, we will store the value of A in some previous variable. Okay, so after termination of that while loop, what will be the value of A? A was pointing to 3x square in the last iteration of this loop. After that A become null. Okay, but before updating the value of A to null, we will store the value of this last node in the previous variable. So when you come out of that while loop, previous is equal to A. So previous is equal to 3x square and A is equal to null. Okay, now what we will do? We will perform this connectivity and we will add this 6x square, 6x here. So this is nothing but 3x square plus 6x. Okay, now we will check if A is equal to null. Is it true? Yes, it is true, because the list is already exhausted, because all the exponent of all the term of the resultant are larger than the temp3. Then what we will do? Previous arrow link is equal to temp3. What was the value of previous? The value of previous was 3x square. Earlier the link part of this was null. Now we are updating the link part of this. Now we are saying that previous arrow link is equal to temp3. So previous arrow link is equal to temp3. It means that 3x square is now pointing to 6x. This was case A. See the second possibility. Now suppose at any point of time you generated temp3, then you will get 4x to the power 3. Now I will get the proper position of this 4x to the power 3. First I start comparison with the first node of the resultant linked list. What is the exponent part of this? The exponent is 5, which is larger than 3. Then we will advance this node. Okay, Then you come here, what is the exponent of this node? The exponent is 4. Once again we advance this node. Then you come at 3x square. Then once again we will check what is the exponent of this 2. What is the exponent of newly created node? 3. So this 2 is not larger than 3 and this 2 is not equal to 3. Okay, then what we will do, what should be the proper position of this 4x cube? This 4x cube should come in between of this 2x to the power 4 and 3x square. So this 4x cube should come in between of this. Okay, when you come here, then the updated value of a is nothing but 3x square. Updated value of a is 3x square, but what is my previous? Previous is equal to 2x to the power 4. So I will made two connectivity. So this should point to this temp3 and temp3 should point to this. Okay, see this C case. If a is equal to null, this condition is not true. You come in the else part, then you compare the exponent of this and the exponent of temp3. Okay, what is the updated value of a? The updated value of a is 3x square. Then I compare this exponent. This exponent is 2, this exponent is 3. Okay, this condition is false. Once again you come in the else part. Okay, then previous arrow link is equal to temp3. What is previous? Previous is equal to 2x to the power 4. 2x to the power 4 arrow link is equal to temp3 means 4x to the power 3, and we will update the link of temp3. Temp3 arrow link is equal to 3x square. 3x square is stored in that a. So this is my second statement. Temp3 arrow a link is equal to a. This is case C. See the last possibility. What is the last possibility? This was the partial result, and at some point of time you created temp3 and temp3 is equal to 4x to the power 3. Now what we will do? We will compare this 5x to the power 5, 4x to the power 4. 4 is larger than 3. Then once again you jump here. Then the exponent is 3. This exponent is not larger than the exponent of the temp3. You come out of that while loop. When you come out of that while loop, your a is 3x to the power 3 and your previous is 2x to the power 4. Then you will compare the exponent of a and the exponent of temp3. The exponent of a is also 3. The exponent of temp3 is also 3. Now what you will do? See, a arrow exponent is same as temp3 arrow exponent. Then what you will do? In this case, you are not going to add that newly created node in the resultant. Just simply what we will do? We will simply do a arrow c is equal to a arrow c plus temp3 arrow c. What is the meaning of this? Means x to the power 3 term is already there in the resultant part. X to the power 3 term is already there in the resultant part, and we have already created one more term with x to the power 3. Okay, so this 3x to the power 3 and 4x to the power 3 should come at the same place, but the exponent will remain same. So, but the coefficient will be 3 plus 4, that is 7. So that's what we are doing here. So a arrow c, a is equal to a arrow c plus temp3 arrow c. Okay, so these are the three cases, a, c and b. After doing this thing, temp2 is advanced. What was temp2? Earlier, temp2 was pointing to the first node of second polynomial. Okay, now we are performing this temp2 arrow. Temp2 is equal to temp2 arrow link. Now this time temp2 is pointing to the second node of second polynomial. Okay, once again you jump in the in this while loop, and once again you will perform the multiplication. Which multiplication? This time first node of first polynomial is get multiplied to the second node of second polynomial. Okay, so this loop is get continued till what? This loop is continued till temp2 is equal to null. When the second polynomial is exhausted completely, then you come out of this while loop. When you come out of this while loop, then temp1 is incremented. Temp1 become temp1 arrow link. Once again you jump in the outer while loop, and once again the same process will start. Then temp2 is reinitialized with head2, and the same process will get continued. Okay, so this is all about the polynomial multiplication, and these are the three cases. The analysis of this polynomial multiplication, suppose m and n are the number of nodes in the first and second polynomial respectively. What we are doing in the polynomial multiplication, first node of first polynomial is get multiplied to all the nodes of second polynomial. Similarly, second node of first polynomial is get multiplied to all the nodes of second polynomial and so on. Okay. The space complexity will be order of m plus n. The best case, worst case and average case analysis, all three will be same, because in all these three conditions we'll be doing with the same multiplication process. The time complexity will be order of m multiplied by n, where m is the number of nodes in first polynomial and n is the number of nodes in second polynomial. Thank you.